Good afternoon and welcome to the U.S. Center. We're thrilled that you all have joined us this afternoon for a candid discussion on climate and the energy, water, food nexus. I'm sure that you'll find the panelists' insights and experience extremely meaningful and insightful. Today, I have the great privilege of introducing 4 distinguished speakers, each of whom has great insights on how challenges associated with this nexus can be conquered. First, it's my great pleasure to introduce Dr. John Holdren, who joins us from Washington, D.C., where he serves as Assistant to the President for Science and Technology, Director of the White House Office of Science and Technology, and co-chair of the President's Council of Advisors on Science and Technology. Prior to joining the White House, Dr. Holdren was a distinguished professor and director of science, technology, and public policy at Harvard University's Kennedy School of Government. As Dr. Holdren holds advanced degrees in aerospace engineering and theoretical plasma physics from MIT and Stanford, his impressive academic credentials match his extensive experience. Next, it's my great honor to introduce Governor Jay Inslee. Elected to Congress in 1992, the governor served 3 terms representing Yakima County in the eastern half of the state and later Puget Sound on the western side. During his time in Congress, Governor Inslee became known as a forward-thinking leader, especially on environmental issues. In 2012, he was elected governor of Washington State, where he's focused on jobs, education, and clean energy. And next, it's my pleasure to present Dr. Katherine Sullivan, who also joins us from Washington, where she serves as the Undersecretary of Commerce for Oceans and Atmosphere, as well as the administrator of the National Oceanic and Atmospheric Administration. She's not only a distinguished scientist and oceanographer, but a renowned astronaut. In fact, Dr. Sullivan was the first American woman to walk in space, flying on 3 shuttle missions during her 15-year tenure. Clearly, Dr. Sullivan is at the forefront of the domains of air and space. And finally, I'd like to present Dr. Jeff Seabright, who serves as Unilever's Chief Sustainability Officer and most recently was Vice President for Environment and Water at the Coca-Cola Company. Jeff has served as a Foreign Service Officer in the U.S. Department of State and also as a legislative assistant to Senators Timothy Wirth and John Rockefeller IV. All of these panelists are foremost experts in their field, so please join me in giving them a warm welcome.
Works. Well, thank you very much, Uzra, and it's a real pleasure to be here with this amazingly distinguished panel to talk about the interaction between climate change and the nexus of food, water, and energy. It's also a pleasure to thank the folks who have come in person and to welcome those who are watching us online. It's an exciting topic, I think, an important topic, and it's a complicated topic by the very nature of the interactions among these different dimensions. I think most everybody understands that there is a nexus of multiple interactions that link issues of food and water and energy. We all know that water is required to grow food. Not everybody knows that typically 70% of all of human withdrawals of water are for irrigation in agriculture, 70%. In many places, it's higher. I think in California, where I spent many years, it's 85% of withdrawals are for agriculture. But we also know that water is required extensively in the energy system. It's required to extract fossil fuels and to process them, to cool power plants, to irrigate biofuel plantations, to generate hydropower, among other functions. And similarly, energy is required to get water. It's required to pump water, to treat water, to transport water over long distances, It's required to remove the salts from seawater and brackish water in circumstances where that's deemed desirable and affordable. And in fact, desalination could become a very large source of demand on our electricity system should it be used on a very large scale. And of course, in situations of longer and more intense droughts in many parts of the world, people are looking very closely at precisely that possibility. The uses of energy in the water system also extend to the energy and the food system embodied in growing crops, transporting crops from the farm to the market, and more. So that was already a complicated nexus. There are competing uses, of course, for all of these important components of our well-being. Water must meet many competing uses, energy many competing uses, the photosynthetic product of the biosphere many competing uses. You have all these interactions, and then it's compounded by the growth of the human population, the growth of economic expectations. If you simply look at sort of the middle of the road United Nations projections, by 2050, the population is expected to reach 9 billion people, the population of the world. They're expected to require by then 80% more energy, 60% more food, 55% more water than we're using today. Those intensifying demands on a set of resources that are already in many respects interlinked and in some respects in competition with one another makes an even more complicated problem. And now you overlay on it the challenges of climate change. And climate change is aggravating the tensions associated with those interactions in many different ways. Climate is changing in ways that are shifting circulation patterns. And together with the unevenness of warming and uneven evaporation, that is altering the geographic distribution of precipitation. And again, contributing to additional challenges in both the water availability space and the food production space. Prolonged droughts not only have impact on food production, they can diminish electric power production that is water dependent, hydropower production, even the production of thermal power plants that require water for cooling can be curtailed in times of drought. We have a situation where a warmer atmosphere holds more water. This is fundamental physics. And an atmosphere that is holding more water can drop more of it at once. And so we are seeing more torrential downpours and more flooding that is associated with torrential downpours. This is happening all across the United States. The National Climate Assessment of some months ago showed that the fraction of total precipitation that is falling in extreme events has gone up all over the United States. It's gone up actually most of all in the Northeast. It's gone up by about 75% over the last few decades. And this is a serious problem. One of the things about more rain coming in heavy downpours, by the way, is more of it is lost to flood runoff. You think, well, at least we're getting more rain, but in fact we're capturing less of it, and the soil is capturing less of it because those extreme downpours run off more rapidly. Often they take a lot of soil with them, aggravating problems for the agricultural sector. And so you've got a very strong linkage with climate there. We're seeing increased frequency and intensity of the most powerful storms that can damage energy infrastructure, can damage water infrastructure, damaging, of course, also to agriculture. And we have hotter summers that are leading to greater energy demands for cooling at the same time as they are putting increased stress on the energy system. So we really have a complicated nexus of problems here. And what we really want to focus on in this conversation is, of course, not just the problems, but the solutions. We want to get people to talk about the effects of the food, energy, water nexus and its interaction with growth and with climate change in their own domains of activity and expertise. But we also want them to talk about what's going on in their domains and their jurisdictions to address these tensions and to manage the issues that come out of the interaction of food, energy, water, growth, and climate change. So I'm, without further ado, going to pass the microphone to my friend Governor Jay Inslee, who, as already noted in the introductions, has been a leader both in the Congress and now as governor of the state of Washington in dealing with the array of challenges that we have in relation to resources, environment, and climate change. Governor Inslee.
Thank you. I have to tell you, I approach this mic with a little humility because I'm not a doctorate in plasma physics, nor am I an astronaut, but I do know what's going on in the state of Washington. And so I can report to you what's going on in the state of Washington. And it's the best of times and it's the worst of times on the score of water and food in that nexus, in a way that I'll share a couple stories with you. It is the worst of times because in one of the most prolifically productive places on earth from the standpoint of growing food, the state of Washington, we've got big time problems associated with the fact that because we have an energy system that has put unbelievable amounts of carbon dioxide in the atmosphere, we are having a damaged ability to be able to feed and wine and dine people in the state of Washington. I'll give you just a little tiny glimpse of what's gone on in the state of Washington in the last 12 months. We grow the world's best apples. We're singularly the world's most productive wheat growing area in the world today per acre in Walla Walla, Washington. We have a wine production for the last 6 years in a row, has had the highest percentage of wine in the world, rated excellent than any other area in the entire world. And I'll get into an argument with Governor Brown about that, but that's just the facts right now. So we got tremendous things going on in our agricultural sector. And this is personal for me because I used to live in the Yakima Valley, and I'd have an apple on the way to work every day in the apple orchards that I live next to, and I used to grow some of the best horse feed hay in the Yakima Valley. So it's kind of personal for me. But the ag industry is getting very damaged because of our lack of irrigation supplies. And we've had the lack of irrigation supplies because our irrigation is dependent on snow. And John hit just the bullseye on this. It's not water or rain that allows us to be so prolifically productive in agriculture, it's snow. Because we store snow that runs off slowly, that feeds our irrigation system, and 2/3 of our state of Washington is semi-arid. People don't really understand that. That depends on irrigation supply. And this year I had declared a statewide drought, statewide. It was not only for the irrigated area, our statewide drought was so severe that in the rainiest city in the United States, that's Forks, Washington, they had to have water restrictions and domestic water usage. So you can imagine how much that is scaring an orchardist that has a multi-million-dollar investment in his or her orchard that may curtail supplies if we get hit for the third year in a row in drought because of our lack of snow. So as John said, we've had some copious rainstorms in our state, but it all runs off as rain, and we can't have it available for our orchards and our hops producing and our vineyards in July and August and September in those dry months. So we have a big problem, and that's very distressing to me because we got huge agricultural potential. We think we can double our wine production in the state of Washington in the next 12 to 15 years, but not if we don't have water to really supply these areas. And that snow also is a battery. That snow is a battery for our manufacturers because our manufacturers, from airplanes to solar panels, depend on electricity from the storage of snow that feeds our hydroelectric system. And we've got the most prolific hydroelectric system in the world in the Columbia River system. So this is a twofer threat. So it's the worst of times when it comes to energy and what carbon has done to our system. But it is the best of times because at the same time we're growing a clean energy economy in the state of Washington. Right now, You want to know where the world's largest producer of carbon fiber that goes into electric cars so you can make electric cars really light? It's in Moses Lake, Washington, that's spinning out carbon that goes into the BMW electric car. You want to know where one of the world's most cost-effective and efficient solar panel manufacturers in the world today is? It's in Bellingham, Washington, at the iTech company. And if you'd like to know where the world's largest, or at least the Western Hemisphere's largest manufacturer of vanadium flow reflux batteries, it's in Mucklety and Pullman, Washington, where we're making grid scale batteries so you can plug in a battery to even out your grid to allow renewable sources for solar and wind to come in to the grid without undue dislocation. So we're building a clean energy infrastructure that means jobs. We've had a 19% increase in our jobs, over 70,000 new jobs in the last 5 years in our region associated in clean energy. So this is both a challenge for us and an opportunity for my state, and we are realizing both. And I have to tell you, I'm inspired that there's something like 50,000 people from around the world who are getting together this week in Paris to try to figure out how to ameliorate that challenge and grow a clean energy economy. And I'm excited about what's going on. And it's not just my state. I just came from getting a ride in a lithium metal polymer battery tram and car. That's pretty exciting what's going on in the world today. So good news, bad news. That's the story from the state of Washington.
Thank you, Jay. So I work at the United States National Oceanic and Atmospheric Administration. And our niche in this, our role in all of this, is really to be America's premier source of environmental information. I don't mean science data, and I don't mean just journal papers, but actionable, timely information that's oriented towards and delivered in ways that are readily useful to aviators, to governors, to mayors. And so I just want to make a few brief remarks and set up a couple of points here. One is we've been talking in a bit of a removed way, other than the governor telling very real stories about how the consequences are being felt by people out on the ground. But if you zoom back and look at this at the full scale of global populations, the availability, the issues of water, too much water in floods, too little water in droughts, of the wrong quality, saline water intruding into aquifers that people have been able to drink from or into agricultural lands, too much, too little in the wrong place or of the wrong quality. The World Economic Forum just this past January identified systemic water issues as among their top 10 global risks facing the planet in the next decade. It is everywhere, and it is pinching already everywhere. What NOAA plays in all of this is the role of scientific information integrator and provider. And so we've got food and energy and water. We have the human needs that thread through all of those. We also have to remember that we have the needs of the natural environment itself. We've got to have forests and the natural hydrologic cycle sustained in its own right, and the ecosystems on which this planet thrives able to sustain themselves as well. So all of those demands are tugging on the same drop of water because this planet only has one integrated hydrologic cycle. Right now, we don't scientifically have very good abilities to look at that and deal with that in an integrated way. Some water data is collected at certain scales by some agencies or jurisdictions. It's often collected in different formats, stored in different manners. I often use the metaphor that we've each stuffed a little water data in our sock drawer, and it becomes hard to pull it together and get the integrated picture. And furthermore, we also have not yet developed the modeling capability that lets us incorporate an integrated set of water data and really look in a holistic fashion at all of these supply drivers and all of these demand drivers on the water cycle. So we'll have modeling of the water needs for the energy production or transmission sector, but not coupled to that a look at how the competing food demands and simultaneous food demands are adding to or complementing that strain. This is what NOAA is really committed to working on. We need a comprehensive, interoperable approach to water monitoring, to water data, to water modeling. We believe that's an absolutely first-order step that's needed to be able to handle the kinds of risks that the World Economic Forum has talked about and that countries and states like the governors are already experiencing. Second point that's right at the center point of what NOAA is working on is our ability to manage risks. We all know this in our everyday life. Our ability to manage risks is strengthened always to the degree that we have some reliable foresight about the kind of conditions we have to prepare ourselves to deal with. And that brings us to the point of practical prediction, the ability to have reliable models that let us predict future states or future budgets and availabilities of water, and think ahead, plan ahead, and prepare ahead for different scenarios. Evaluate different courses of action. Test them against public needs, against policy constraints, against business drivers. We're doing a number of things at NOAA to help advance this capability. We're doing some of the fundamental science along with other partners in the United States government to advance our understanding of the interconnections between these sectors and understand the fundamental dynamics of the planet's hydrologic cycle. We're working hard to improve the monitoring and measuring systems that give us stream flow and precipitation and allow us to create a more reliable and accurate real-time budget. We're working very hard to integrate data systems and to develop an integrated modeling capability. And just earlier this year, to help really catalyze all of this forward, we opened a new National Water Center on the campus of one of our major universities. NOAA will operate this facility, but it is already a place where our Geological Survey, one of our key water management agencies, our Federal Emergency Management Authority, academic scientists, water users and consumers, as well as NOAA scientists, will come together to look at the whole spectrum from fundamental research to information and application needs, and drive, with this center functioning as a test bed and an accelerator, drive the progress of science and measurement into information and into action. We believe that really these couple of steps, integrated water data and integrated water prediction, are indispensable. We can't look at water in a holistic sense from a hazards point of view unless we advance this capability. We also can't really get at the competing demands that both John and the governor talked about if we don't bring this into a more holistic focus. Achieving that will certainly require further advances in cutting-edge and provocative research, but at least as important, it's going to require connecting different domains of information and connecting different user perspectives and understanding of community needs. So it's exciting times. I would agree with Jay's characterization. I wish we had this now. We would all be better served and better equipped to look ahead and tackle some of these issues. And my agency sits side by side with all of the California water agencies, for example, and is working on a minute-by-minute basis to try to understand these competing demands and make the best possible judgments about water management in California. We all wish we could give those both corporations and communities and public officials a 90-day or 100-day forecast of what the actual total water would be. It would revolutionize their ability to help California through the crisis, and it would be just what the governor and his ranchers would like to bring to bear as well. So work in progress. I want to thank, before I close, John and his colleagues at our Office of Science and Technology Policy. They have really seized the mantle on this, formed a new task force at the White House level to make sure that all of the U.S. federal agencies are really combining and bringing their energies together in the most constructive way to accelerate our progress at delivering the information tools and services that can help our country deal with this integration and the challenges of these competing demands around this nexus.
Great. Well, thank you very much, and thanks for the opportunity to share some thoughts today. I'm not a plasma physicist, I'm not a governor, nor am I an astronaut. I work for a company that sells soup and soap, but it's 400 brands and that we sell in 190 countries, touching 2 billion consumers every day. So quite a large global operation. And this agenda is front and center for my company, for Unilever. It was also front and center for the company that I worked for previously, the Coca-Cola company. And in that capacity, Katherine just mentioned the World Economic Forum. In 2009, I had the privilege of chairing the Water Security Agenda Council for the World Economic Forum. And we quickly realized that if we really were to understand water in its entirety, we had to really look at this nexus of water, food, energy, and as John rightly noted, the sort of the demographic and economic, the rising middle class pressures, that stress that interaction of food, energy, water, and the very important stress that climate change increasingly is putting on that, especially in the medium of water through which climate impacts are being most manifest. And I would add to that it's not just food, but it's food and forests, because forests are also critical for water resources, but they're also big drivers in terms of deforestation of climate impacts, and I'll come back to that in a moment. So I would say food and forests, not just food. But these interdependencies are critical. 20% of the electricity that is used in California is used to move, transport, and heat water. So every time you flush a toilet, you're emitting greenhouse gases. Half of the water in the US that's withdrawn from surface water is used to cool thermoelectric power plants. And when there is water stress or drought, as there was in Atlanta when I was working at Coca-Cola, Georgia Power nearly had to shut down 2 of its facilities because they didn't have enough water to cool the power plants. And you can imagine the impacts that has for business and for all of us. The drought in Atlanta that occurred 6 years ago required companies like Coca-Cola to shift production out of Atlanta because there wasn't enough water based on the water stress. So we're seeing more and more indications of this nexus, and the real challenge of understanding sort of both the synergies, but also the embedded risks and how they can play on each other. At Unilever, one of the things that we've been focused on is really understanding the climate impacts for our business. We estimate last year $400 million of our business was negatively impacted. The cost of climate for our business was about $400 million. Just last year alone, or this year in Brazil, the tremendous drought in Sao Paulo cost us about $80 million. People shower less, they wash their clothes less. Our manufacturing facilities had to put in backup generators because the hydroelectric situation required water, electricity rationing. We couldn't deploy ice cream freezers. We're the largest seller of ice cream in the world, and that hurt our business. It was a very material impact in this interconnected agenda of energy and water in that particular instance. We're also, though, looking at how we can, in a sense, insulate our business and help risk-proof our business, climate-proof our business for these risks going forward. So, one of the goals that we've set for ourselves, in addition to being 100% renewable energy use in the U.S. already, is to be 100% renewable by 2020 globally, and to be carbon positive in our global operations by 2030. But we're also learning, as we set goals around reducing consumer use, the amount of greenhouse gas emissions associated with our consumer use of our products, and the amount of water. And it turns out, as we've done the analysis across our entire value chain, and I mentioned we serve 2 billion consumers, so you can imagine the data involved in that, but the single largest driver of greenhouse gas emissions across our value chain, from farm all the way to consumption, is hot water heating in North America for showers. And so that, the data, the analytics, really help you understand where you can focus in on some of the solution sets. So let me just close by saying, some of the things that we're working on, I think, in this space in terms of innovation to address some of the embedded risks and also opportunities. Don't have to be, a scientist to understand that with increased water stress, the ability to perform basic things like clothes washing with less water becomes a very important attribute if you're a consumer products company. So our innovation team in India has been hard at work coming up with a single rinse hand wash detergent that will allow a third less water to be used to generate the same effective impact in terms of clothes washing. Dry shampoo, new category, it's done quite well in Brazil without a lot of water. So we're seeing how these consumer patterns begin to shift and how we need to shift our innovation and the offering, because we're not offering, to offer the right services at the least resource impact. We're also looking at, in agriculture, we're seeing the stresses in agriculture and the variability in our agricultural supply chain, the impacts of drought, the impacts of heat waves, and how that has driven tremendous variability in commodity pricing. We also are seeing the challenges around working closely on that farm forest nexus. So palm oil, we're the largest buyer of palm oil in the world, which has been historically associated with tropical deforestation and climate impacts. You know, how do we engage aggressively with smallholder farmers to improve their productivity, increase their resilience to climate impacts, and provide ample opportunity for them to generate double, triple yields and not have to deforest in order to advance their livelihoods. We announced with Secretary Jewell on Monday of this week our intent to put our procurement team behind jurisdictions, local jurisdictions that are working hard on good land use policy, and we want to be associated with sort of the support for their produce and protect approach to responsible land use management. So that's an innovation, not so much on technology and hardware, but around business models and how we work together with the public sector. And I would just finish by noting that data, which Katherine talked about, vitally important. And so the ability to really understand the challenges, I think the work that WRI is doing on their project with Aqueduct is critically important. Global Forest Watch, we're seeing a host of new powerful tools using GIS and satellite technology to help integrate data sets and to better understand those linkages and to better understand where there are risks and where there are opportunities to get ahead of those risks. So those are just some quick thoughts from a business perspective, and I look forward to the questions and discussion.
Great, thank you. Before we open it up to questions from the audience, I'm going to ask a quick question of each of the panelists, get things going in the Q&A part of this presentation. Let me start with Governor Inslee. I wonder if you would comment on how the federal government could be more useful to your state as you confront the challenges of managing the food, water, energy nexus in the face of a changing climate. What more could the federal government be doing to be of assistance to you? And to make this fully germane to the whole panel, what more could the private sector be doing to help manage these challenges in the state of Washington?
So in answer to this question about what could the federal government do, let me just tell you a little story. I was at Port Angeles at, as I recall, Stevens Middle School a couple months ago, and I was in an 8th grade class, and I asked the kids, I said, how many people believe that climate change is happening because we're putting too much carbon pollution in the atmosphere? And every single hand went up of those 8th graders. These are 8th graders, understood the basic science behind of this. And then I asked them, how many people think we should maybe do something about this? And every single hand went up of a bunch of 8th graders in Port Angeles, Washington. Wouldn't it be a delightful thing if we had a U.S. Congress where if you ask them if we should do something about climate change, more than 50% of them would put up their hands and say yes. And I think, thank you, I think that's a wonderful thing. That's what the nation needs. We don't have it right now. We have enough folks that constitute a majority in the House of Representatives that don't want to recognize the clear science that 8th graders understand across the United States. And I hope that'll change. Until it changes, we need governors and mayors and county council people and CEOs of major corporations to take the lead on this. And I can tell you the good news is that is actually happening. I've been involved in discussions here in the last 3 days that have seen very, very common sense things that are going on at a local level. We have a Pacific Coast collaborative that are working up and down the Pacific Coast, California, Oregon, Washington, British Columbia, working together to constrain carbon pollution to save this beautiful area. I've just met with the Premier of Ontario, and last night with the Premier of Quebec, and today with the Minister of Environment, I believe it is, of Alberta, all of whom are working to have common sense policies to reduce carbon pollution. So we can't wait for this frozen, broken system in the U.S. Congress. We got to move right now. Our grandkids deserve it. And I can tell you we are moving right now. So, John, my answer is we're not going to wait for them. We can't wait that long.
All right. You didn't do the private sector, but we'll
Let me mention the private. We got great private sector leadership, too. Microsoft has an embedded carbon price of their internal operations. So every expenditure at Microsoft now has an embedded cost of carbon so that the Microsoft Corporation can make internal decisions that embed the cost of carbon pollution to our grandkids. It's a wonderful thing. And we're seeing that throughout corporate America. Corporate America is way ahead of the Congress on this. And hallelujah, we got some corporate leaders that understand this.
All right, my next question is going to go to Dr. Sullivan. As we think about how we cope with climate change, we always come to the conclusion that we need both mitigation, reductions in the emissions that are driving climate change, and we need adaptation, preparedness, and resilience to cope with the changes that are ongoing. The sectors we've been talking about embody both dimensions. That is, the energy system is the source of a lot of the greenhouse gas emissions. The second biggest source is land use change, including the uses of land for agriculture. And at the same time, these sectors are influenced, as we've been discussing, by climate change. How can the kinds of data that NOAA develops, collects, massages, and makes available assist as we confront both sides of this equation, the mitigation side and the adaptation, preparedness, resilience side, particularly with respect to these sectors?
Yeah, it's a great question, and I'll answer on two levels. We're living this, we're learning this, because this is a continually changing set of circumstances we're all dealing with. We're learning this in part through an agreement we have with the Western Governors Association, which is also a fairly conservative group of individuals politically, but they're seeing and hearing from their utility companies, from their ranchers, from their orchardists and agriculturalists, that circumstances are changing on the ground around the availability of water and their uses and their needs. And they are hungry for information about the hydrologic cycle, about the availability of water, and about possible scenarios for future conditions so that they can start to factor those potential futures into their business plans, into their insurance, into their planting, the whole array of levers that folks in those sectors have. But without some ability to do more than just speculate, you can either speculate or you can worry, or you can develop some predictive capability that puts some more reliability around your data signal. People will use that kind of information to hedge their bets. And in the early stages of this, I think we're seeing a lot of interesting moves by people with a reliability of prediction far below what we would hope to attain eventually scientifically, but indicative, reliable, scientifically reliable information that gives an indicative prediction that says you need to set yourself up to be prepared to deal with something in this range of circumstances. That is the kind of information that can develop or provide enough insight to begin making business strategy changes. So that's one thing that what we're learning out of that at NOAA is NOAA produces 20 terabytes of data about the planet every single day. None of these people need those 20 terabytes. They need some dollop of that data. And in fact, they don't need it as data. They need it as information that fits in their decision framework, that's kind of can insert readily into the set of variables or levers that they can interact with to affect a more viable, a more productive, and a more sustainable future for their business or for their state. So what we're trying to learn as NOAA is how to be the center link between the world of science and the abundance of data that's produced by satellite data streams and everything else, and the information needs, the more tangible information needs of real actors in the real world, and be the transformer and the broker, and sometimes the translator, and sometimes the instructor, if you will, to help people appreciate how to use the data in their world. So we're doing that through the Western Governors Association. We're doing that with other federal partners through national drought partnerships that are oriented towards this transformation and delivery of information. And I think that's the process flow we need to continue to improve.
Great. So, Jeff Seabright, since I've known you and admired what you do for so long, I'm going to feel free to ask you the hardest question. And the hardest question is this. The private sector has been stepping up in an extraordinary way, both in terms of mitigation and adaptation, preparedness, and resilience. We now have over 150 companies in the American Business Acts on Climate Pledge. What I'd like to ask you is, what are the respects in which the federal government, the state government, or the international community of governments represented here at COP-21 could improve the situation from your standpoint, from the private sector standpoint, so that you could do more? Are there proactive things that state, federal, and other national governments should be doing? Are there things that we should be subtracting? Are there ways in which we could get out of your way? The private sector is already a great contributor, but we needed to do even more. What do we need to do to help you do that?
Well, I mean, I think it starts, John, great question. I think it starts with finishing this negotiation with a very strong and very clear signal about the long-term ambition, right? And so, we're advocating for net zero by 2050, 1.5 degrees, that's our position. But I think sending a very clear signal, having very clear pledge and review, will send a very strong signal to the business community, because this is a negotiation between and among governments, but it's also a signal to the private sector. So what comes out of here will send a very strong signal to the business community. And there's been a very rich dialogue, and I think an evolution of the dialogue, as you note, in the business community, where this agenda was looked at, 5-10 years ago as it's an either/or. We're going to have to address climate at the expense of, and it's now seen as an opportunity. The low carbon economy, the new climate economy work that President Calderon and Nick Stern led, I think we're seeing more and more evidence of that, and more businesses putting an internal price on carbon, making their business plans with this in mind. And I think having a strong signal at the international level, having a strong signal at the national level, and obviously great partnerships at the local level will really help embolden business to unlock the innovation potential, the financial capital, the human ingenuity that is at the heart of what the business community can do best. And we can solve this. I mean, we can do this together, but we need a strong signal. And so I think that, to me, is number one. There are a whole lot of things that stand in the way of that today that are challenges, but I think the most important is that.
Great, thank you very much. Let us open it up to questions from the audience. I think we have a microphone that can be passed around. If you want to ask a question, raise your hand, get the attention of the man with the microphone, and let me emphasize that a question is not more than 2 sentences, the second of which ends in a question mark.
Governor Inslee, you've spoken eloquently about the nexus of climate change, and I want to move that into the policy issue. I represent the Presbyterian Church USA and the Idaho Conservation League. From a policy perspective, how will you balance the questions of coal export terminals at Cherry Point and Longview with the clear impact of the potential 95 million tons of coal being shipped to East Asia and coming back as pollution affecting Washington agriculture?
Yeah, the question about, if you couldn't hear it, is about potential coal ports, export ports from the state of Washington. And we have several of them now, both coal and oil, potentially in a permitting process. And I cannot take an up or down position on any of those because I'm a permitter on those right now. But I can describe the process to you, how we're going about that decision. The first thing people need to know on is, first, we're going to follow the law in that permitting decision. It's important for me to say that. But second, what we're going to do is to make sure that our state citizens are aware of the carbon dioxide pollution that would be associated with the burning of the fuels that would be exported from these facilities, no matter where that fuel is burned. So in our environmental impact statements, we are insisting that the applicants provide information to our citizens about that carbon dioxide that will be generated from the burning of that fuel. That is both the right and the legal thing to do, because no matter where this fuel is burned, it ends up in Puget Sound. So even though you ship coal out of Puget Sound or West Coast ports, it ends up getting back in Puget Sound. And this is a big concern of mine, because it's not just changing the climate, it's actually changing the acid-base balance of the waters of my state. And the waters of my state have been very, very damaged by carbon pollution since we started burning coal over a century ago. In fact, the waters of my state are 30% more acidic than they were before the Industrial Revolution, because the carbon dioxide from burning coal anywhere in the world ends up acidifying the waters of the Pacific Coast and Puget Sound. And that is having a marked change in the biological activity in my state, because the whole food chain is based on these little critters that you can't basically even see with your eye, but 40% of them have a calcium carbonate-based life support. Their structure is calcium carbonate, and as the waters become more acidic, those little critters essentially melt. And I don't know if melt is the correct terminology, but they corrode. They end up losing structural mass, and you actually can see that happening today, particularly in the Arctic, where you have even more corrosive waters. So it's very, very disturbing to me. Ocean acidification is the kind of the evil twin of climate change, and we're going to insist that our citizens know the implications of that before any no-go or no-go decisions are made on these permits.
Any more? All right. Well, you guys okay if we take two at a time?
I'm Kalyan Chakrabarti. I'm from India. I was just thinking about how the private sector is, I mean, there's a lot of consumerism, and because of that, you were saying that there's need for water in the private sector. There is also, therefore, the use of a lot of energy. I was just wondering whether in future, the private sector will agree to something called a carbon footprint and a carbon tax. Like some of the goods which are there, ultimately, some of them use a lot more of water, a lot more of energy, and thereby release a lot of carbon dioxide. Would you be ready for a carbon tax on each of the products in the future, in A? And would you make a distinction between, most of the products which are made are basically for wants and not for needs because of a lot of consumerisms? Will there be a differential tax on that? Would we be agreeable to that in the future?
Hold off on answering that. We'll get one more question. Please introduce yourself.
Thanks so much. I want to ask you questions about the global solution to energy, water, next to security. And what's your opinion on global cooperation or global data cooperation, just for U.S. and other major powers, particularly for Central Asia or Southeast Asian regions? Thanks so much.
Okay, I'm going to take a quick cut at a couple parts of this, and then I'm going to just pass the microphone down so that each person can make a final comment. We've got about 7 minutes left in this session. When I think about the policies that are needed to advance the mitigation of climate change, to reduce the emissions that are driving the problem, I think there are three sets of measures that each require a set of policies to deal with. The first set of measures are measures that are economic under current circumstances, would make complete sense, but are not being fully embraced because of various barriers to sensible action. Barriers like lack of information, barriers like lack of financing to invest even in opportunities that would yield a high rate of return if you invested in them. A lot of the energy efficiency opportunities fall in that space. I call this the low-hanging fruit, but there's a fence around the tree. And so we need policies to take the fence down. In the middle of the range of options are options that are somewhat more expensive. They're not quite economic under current circumstances. This is the fruit that's somewhat higher in the tree. For that, we need incentives to motivate people to reach higher into the tree to grab that fruit. A number of the alternative energy supply options are currently in that category. Although the fruit is coming down over time, more and more within reach, we need either a price on carbon emissions to incentivize reaching higher into the tree, or as a second best set of options, we need policies such as regulation that produce an incentive in the same direction but less efficiently. That is the domain of policy in which today we are most lacking. And in the United States, of course, there is no real way to set an actual price on carbon without the agreement of the Congress, and we're not getting there, and so we are using policies that are at our disposal to create a second best alternative to motivate reaching higher into the tree. On the far end of the spectrum of possible responses, there are technologies that are today much too expensive or otherwise out of reach. Carbon capture and sequestration for fossil fuel power plants is a good example. Fusion energy is another example. There, what we need is energy research, development, and demonstration to lower that highest hanging fruit into reach of reasonable incentives. And again, it's kind of odd that today in the spectrum of energy policies, we're doing the stuff to take the fence from around the tree, providing financing, providing information, removing perverse incentives. We're doing the energy research, development, and demonstration. We just announced at this meeting mission innovation, where 20 countries agree to double their investments in clean energy technology research and development. The stuff in the middle is what's most lacking, and again, it's most lacking, unfortunately, because we need our legislatures to do it.
Yeah, I would say there's good news from the state of Washington because we actually are doing all three branches of the tree because we're having good deployment of renewable portfolio. Because of our renewable portfolio standard, we're getting efficiencies, we're getting new renewable energy. That's working. That's the lowest branch, if you will. On the second branch, we now are adopting, and John, I don't know if you even heard about this, but we're doing, under our clean air law, by executive order, we're establishing a cap on carbon for 59% of our economy. So we will have a cap, which will, in essence, put a price on carbon associated with carbon pollution. So we actually are going to get the second branch level, and I'm not the only state. California, Ontario, Quebec, British Columbia, 8 Northeast states. So we're moving in the what's called the subnational level on the second branch. On the third branch, I think we're starting to understand how short we are on research and development funds. And I think we are so short of what we've got to do on research. Give you an example. This may be antiquated now, but 5 years ago, in the utility industry, the entire research and development budget for the utility industries of the United States were less than the R&D budget of the dog food industry in the United States. We are so short of capital in this realm, but we're starting to help. These nations have started to band together. Bill Gates is putting hopefully several $billions with other investments. We heard about this week. My state's doing a little bit. We've established a clean energy fund that's got about $80 million going into deployment of clean energy. So we're starting to do all three branches, and I think we ought to celebrate that because it's none too soon.
Thanks. My points don't fit entirely neatly into John's framework, although I appreciate that framework tremendously. But I would just touch on three additional things. With respect to research and development, I would argue we need to remember this is again about the natural hydrological cycle and how it threads through these human sectors we're talking about, the need for food, the need for water, the need for energy. And I made the point earlier, we have to remember there's a fourth piece here, and that is the natural environment itself. Jeff casts that as forest, but it is also more than that. It is also the governor's salmon that are fighting for the same drop of water with a farmer and with the municipality. So we are nowhere near where we ought to be on research investments in understanding and deepening our understanding of the hydrological cycle and the processes that drive and govern it. We're not where we need to be yet either on measuring and monitoring water. Just to give one point of example, soil moisture is a critical aspect of how the hydrologic cycle actually works. We have pitifully little in situ soil moisture monitoring across the United States. We had an attempt to field a very powerful satellite that could have given us a broad area view, but it needed ground-based calibration to really be useful at all, and it needed a densification to really get the data driven down to the levels that we're talking about here. So don't forget the natural systems themselves as we talk about energy transformation and efficiency and everything else. Research, monitoring, and finally, something that I think is an undercurrent here, if you're going to put information tools out into the community for businesses or governments to use, they really are going to be critically dependent on open data, publicly available, reliably sourced data that anyone can look at, and tools to interrogate that data that anyone can use and anyone can evaluate and anyone can criticize. On that kind of platform, proprietary tools to tailor to different sectors can stand. But if we forget the open data and we forget the open platforms for analytical tools and models, we really won't get where we need to get because we won't have the foundation of trust that it take will really move there.
We left 1 minute for Jeff, who has a train to catch, so I know you'll be brief.
True, absolutely. So 2 questions from my Indian friend here. One is, do we support a carbon tax? Yes. Not just support, but we advocate openly and aggressively for it, along with many other businesses, and I think it's critical that we further raise the level of ambition on that. On your question about a differential tax between human needs and sort of luxury wants is a great question. Up to national governments really to make that call. That's not up to us. What we have done as a business is to focus on embedding social purpose in all of our brands to make sure that what we're doing on nutrition, water access, sanitation, those are the brands that are growing fastest in our portfolio. So we're looking at it through the other end, which is how do we meet human needs in a way that will really help advance our business, but in the process help with moving us all forward. So thanks.
We need clear signals, strong incentives, more investment in R&D, a wider perspective that recognizes the needs of the natural environment as well as the needs of human society for these resources. And we need more cooperation across sectors, across states, across nations in research, in innovation, in the monitoring of the environment and the sharing of data. And with all that, we'll get the job done. Thank you very much.